Hi, this video will show you the example of calculation to determine the order of reaction by using initial rate method.
Now, look at this question. It requires us to determine the rate law and rate constant for the reaction, given the reaction equation and a table of experimental data.
From the reaction equation, we will write the general rate law. Then, we will examine the experimental data in the table and find two experiments in which the concentration of one reactant changes, but the other concentrations are the same.
Let's say we take experiment number 1 and compare with experiment number 2. Here, the concentration of nitrogen dioxide changes, but the concentration of carbon monoxide does not. Now, we will determine by what factor the concentrations of nitrogen dioxide and rates change in these two experiments. As calculated, the concentration of nitrogen dioxide changes by a factor of 2. On the other hand, the rate changes by a factor of 4. Next, we will determine to what power the concentration factor must be raised to equal the rate factor. As calculated, power of n octane is 2. This means that nitrogen dioxide has a second order of reaction. We will repeat these steps for carbon monoxide reactant. Now, we take experiment number 2 and compare with experiment number 3. Here, the concentration of carbon monoxide changes and the concentration of nitrogen dioxide does not. Similarly, we will determine by what factor the concentrations of carbon monoxide and rate change in these two experiments. As calculated, the concentration of carbon monoxide changes by a factor of 2. On the other hand, the rate changes by a factor of 1. Then, we determine the power concentration factor that equals to the rate factor. As calculated, power of m octane is 0. This means that carbon monoxide reactant has a zero order of reaction. Now, we take the general rate law and substitute the n and m with 2 and 0 value respectively. We can now write the complete rate law. We can conclude that the overall order for this reaction is second order. Now, to calculate the rate constant for the reaction, we will take the data from any experiment given. Let's say we take from experiment number 1. Here, we will substitute the initial rate and initial concentration values into our rate law in order to calculate the K value.
Created using Powtoon.